Tired of hardcoding test tokens every time you spin up a FastMCP development server? We'll show you how to set up static token verification that lets you instantly define development credentials with associated permissions. No JWT infrastructure required. You'll see exactly how to map simple string tokens to user identities and scopes, making local testing as simple as adding a bearer token header. From FastMCP, import FastMCP. From FastMCP, server, Auth, providers, JWT import static token verifier, hash-defined development tokens, and their associated claims. Verifier equals static token verifier. Tokens equals dev Alice token. Cliented alice@company.com. Scopes read data, write data, admin users. Dev guest token. Cliented guest user. Scopes read data. Required scopes equals read data. MCP equals FastMCP. Name equals development server. Auth equals verifier. This demonstrates the static token verification pattern, a development-focused authentication approach that replaces dynamic token validation with predefined credentials. The concept treats authentication tokens as configuration rather than runtime artifacts, mapping fixed token strings directly to authorization claims. What makes this distinctive is its complete decoupling from token issuance systems, enabling rapid iteration without external dependencies. The pattern works by establishing a direct mapping between token strings and identity claims at server initialization. Instead of cryptographic validation or network calls, the server performs a simple lookup against the predefined token dictionary, returning the associated claims for authorization decisions. This approach embodies the principle of convention over configuration for development environments, trading production-grade security for immediate usability and zero setup overhead. This matters because it eliminates authentication as a development bottleneck, allowing you to prototype and test authorization logic without standing up token infrastructure. The trade-off is clear. You gain instant productivity during development at the cost of security guarantees that would be mandatory in production. Use this pattern exclusively in development, testing, or controlled demo environments where convenience outweighs security requirements. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool servers. It handles function exposure, type validation, and schema generation for AI model integration. From FastMCP, server, Auth, providers, JWT import static token verifier. Imports static token verifier, a JWT authentication provider that validates static development tokens. This bypasses complex OAuth flows during local testing while maintaining scope-based authorization. Hash-defined development tokens and their associated claims. Verifier equals static token verifier. This instantiates a static token verifier for development authentication. It replaces dynamic JWT validation with hard-coded tokens, eliminating external auth dependencies during local testing. The pattern is common in dev environments where you need predictable, repeatable auth without real infrastructure. Tokens equals. This defines a hard-coded token-to-claims mapping for development. It simulates JWT verification without requiring a real auth server, letting you test permission flows locally. Each token maps to specific client identities and scopes. Dev Alice token. This defines a development token key for Alice's credentials. The key maps to a dictionary of claims, enabling role-based access control with specific permissions. This pattern centralizes token management during development, eliminating hard-coded credentials in test scripts.
Cliented, alice@company.com.
This defines the client identifier for authentication. In JWT-based systems, cliented uniquely identifies the requesting entity, enabling scope-based authorization and audit logging. Here it associates the token with Alice's development account.
Scopes, read data, write data, admin users.
This defines the token's permission scopes, implementing role-based access control. Each scope string represents a specific capability like data read-write or admin privileges. The server enforces these permissions on every request, preventing unauthorized operations. This closing brace terminates the devguest token configuration dictionary. It completes the token definition, separating it from the next parameter in the static token verifier, initialization.
Devguest token.
This defines a second development token with restricted permissions. The devguest token represents a limited access user, demonstrating role-based authorization in the test environment.
Cliented, guest user.
This defines the client identifier for the guest token, establishing a distinct user identity with restricted permissions. The string guest user becomes the principal name in access control checks, ensuring proper scope enforcement for this limited access credential.
Scopes, read data.
This defines the token's authorized scopes, implementing role-based access control. The array specifies which operations this token can perform, with read data granting read-only access to data endpoints. This follows the Auth2 scopes pattern for granular permission management. This closing brace terminates the token's dictionary definition, finalizing the mapping between development tokens and their associated claims. It's required Python syntax that completes the object initialization before passing it to static token verifier. Without this, the dictionary would remain open, causing a syntax error. This closing brace terminates the token's dictionary definition, finalizing the mapping between development tokens and their associated claims. It's the required syntax to complete dictionary initialization before passing it to static token verifier.
Required scopes equals read data.
This enforces minimum scope requirements for all incoming requests. Any token without at least read data scope is automatically rejected, implementing a baseline access control policy before any tool execution. This closing parenthesis terminates the static token verifier configuration, finalizing the token to claims mapping and required scopes. It locks in the development auth setup before passing it to FastMCP, ensuring only pre-approved tokens with sufficient scopes can access the server.
MCP equals FastMCP. Name equals development server. Auth equals verifier.
Instantiates the FastMCP server with our development configuration. The auth equals verifier parameter enforces JWT token validation using our static token definitions, while the name parameter identifies this instance in logs and metrics. This is the entry point that makes all registered tools AI callable. Static token verification. Development environments often need predefined tokens without JWT infrastructure, and FastMCP's static token verifier provides exactly this by mapping hard-coded tokens to claims. The required scopes parameter filters all tokens, even those with broader defined scopes. This pattern eliminates token generation complexity, while maintaining scope-based authorization.
The token that never changes authorizes every change.